Okay, we're going to be doing machine learning, in particular classification and regression trees. We have cloned scikit-learn, and scikit-learn has those things implemented, but I want to implement it in C++ just because it's fun. And yeah, that's going to be hopefully useful as an exercise for learning machine learning. And then I can use it on the Kaggle Titanic problem. But before we get started, I need to check whether, we're going to close this now. I need to check whether the stream thing is working. Yes, so it's live. Okay, so if I want to check if my mic is fine, can I do that? Well, that's going to be super weird if anyone watches this, right? No, actually, that's fine. Okay, so the mic is okay. So I can close this. All right, where was I? Okay, so right, I literally have zero code. I just set up a CMake project and some dependencies. Did not write anything whatsoever. So we have to start from scratch, and I don't really know much about decision trees. So the first question to answer is, how do I build a decision tree? What is a decision tree? I mean, I know what it is, kind of. It's a tree. So it's going to have nodes. It's going to have a left node and a right node. I believe it's a binary tree, right? Yeah, classification tree it's a decision tree, right? So it has left and right, and then you either go left or right depending on something that's related to these splitters and criterions. Okay, so how do I even get started thinking about this? The function to measure the quality of a split, but what is a split? Supported criteria are Gini, blah blah blah. I'm just gonna implement the Gini impurity, probably. I don't think I'm gonna implement the other ones, but I want to see, like, I want to get started with at least something. So like, I'm gonna obviously need a tree, so I want to see how does scikit-learn actually implement trees. So it has self.tree, right? I want to see what is a tree. Are they using some kind of, is it like something very simple? Did they make it in a simple way? Do they have something special in Python? And I need to think of a way how I'm going to do it in C++. Right, so this thing inherits from, you know what, while I'm reading code, I'm just going to put this on split view so I can have this here and the rest of the code below. Right, so it inherits classifier mixin and base decision tree. So instead of starting with the decision tree classifier, maybe I should just go look at what is a base decision tree. Right. Okay, let's start by looking at a base decision tree. What is a base decision tree? What does it have? Okay, it looks like that's all implemented in one same file. How many lines of code? 2,000, bro. All right, that's kind of weird, because then how do you know which of these dependencies are relevant and which aren't? Annoying. Whatever. Base class for decision trees. Warning, this class should not be used directly. Use derived classes instead. Okay, bro. Check input is used for optimization and isn't something to be passed around in a pipeline. Okay, I don't care. Parameter constraints. I'm guessing that's used somehow by something. I don't think this one uses it. Parameter constraint. No, it doesn't. Okay. So I guess some other, when this thing is doing computation, then it uses those parameter things. Maybe in derived classes, I don't know. Okay, so it has criterion splitter, max depth. That seems to be like a common theme in these decision trees, is that they have criterions and they have splitters. Max depth, that's kind of self-explanatory, but what is a criterion and what is a splitter? Like, I would like to have an example of that. Now we could go, should I read or should I ask an LLM? Let's see. Does this say anything? I mean, the original cart algorithm uses the Gini impurity. Right, used by the cart algorithm. Yeah, but this just says what is a Gini impurity. But it doesn't tell me, or maybe if I read it in more detail, but it doesn't really tell me what is a criterion really, and what is a split. So let's ask. In the context of machine learning, the decision trees, what is a criterion? Is that, did I spell that right? Let's see. I like to talk to Gemini because in Emacs, if the large language model responds with if the large language model responds with something like LaTeX, then it cannot be rendered, which is annoying. All right. This is usually, okay, in the realm of machine learning specifically, a criterion is a mathematical function used to evaluate the quality of a split. But then what is a split? When constructing a decision tree, the algorithm must iteratively partition the data set into smaller subsets. Interesting. Okay, so I'm building this as part of the Titanic Kaggle problem. So we actually have a data set to work with and to experiment with. So we would somehow partition that data set, and we use the Gini coefficient to partition it. Now, why do we partition it? Okay, so let's, okay, so what did we learn? Okay, so when constructing a decision tree, the algorithm partitions the data set split. How it partitions the data set depends on the criterion, Gini impurity. Well, let's put example because there's others. And apparently Gini impurity is not the best, I believe, because some like more advanced algorithms use other criterions, but we're just gonna do the most basic one for now. Okay, the algorithm partitions depends on the criterion, how it partitions. Okay. I mean, that's understandable. The guiding metric, the criterion serves as the guiding metric for determining the most effective feature. Interesting. So the algorithm itself determines the most effective feature, but I imagine that it helps a lot because you do like preliminary data cleanup, and analysis. So first you're obviously gonna like clean out the stuff that's obviously not useful, right? Because I'm working with Titanic dataset. So actually I'm just gonna do that in Colab. Okay. Damn, I'm not good at using Colab. Hold on a second. Right. So we obviously have passenger ID is obviously not useful, right, in classification. And we want to know, like, based on these things, whether a passenger is likely to survive or not. It's obviously way more likely based on the box plot. If you are rich, you have likelihood to survive. If you're poor, you're screwed. So we obviously, but I guess then on its own it can determine things that I'm kind of not sure about, like the number of siblings, parents, children, the cost of the fare. I don't know if those things influence whether you're gonna survive or not. I would imagine cost of the fare does. Did I make a plot for that? I did, and I mean there's little overlap here in the box plot. So that would mean the cost of the fare does impact your likelihood to survive. Okay. All right. To split the data at each node. But I thought we're splitting the data set. So why are now we talking about splitting nodes? Well, maybe I just don't really understand what a node is. Yeah, I have no idea what a node really is in a decision tree. Maybe it's gonna explain it later. So the ultimate goal is to create child nodes that are as pure or homogeneous as possible with respect to the target variable. The choice of criterion depends on whether the decision tree is being used for a classification or a regression task. Oh, okay. So maybe... Okay, so Gini impurity is used for classification, but can be used for regression? The Gini impurity measures the frequency at which a randomly chosen element from a node would be incorrectly labeled. Yeah. And this confusing formula. I mean, it's not confusing, but if I don't have a concept of what a node contains, then this doesn't make sense. But maybe I can like interpret it. So C, I would guess, is that the size of the tree, total number of nodes? What is P? Where C is the number of classes. Okay, so that's either you survived or you didn't. And PI is the probability of a sample belonging to class I. So Gini is 1 minus the sum of whether you right, so Gini is 1 minus the sum of at the node. So, but we're working at the node. This only makes sense in the context of a node. Okay. In regression task, the goal is to predict a continuous numerical value. The criterion for regression trees aims to minimize the variance within the nodes. Okay, so we use mean squared error in regression tasks. Okay. Let's see what is a node. What is a node in a decision tree? What data does it hold? What do we have in a node? And I still didn't really answer the question, what am I splitting, right? Because here it says where to split. Ah, wait, no, I'm stupid. When constructing a decision tree, the algorithm, not the criterion, must iteratively partition the dataset into smaller subsets. Yeah, so this is not correct. No. The criterion is about splitting data at each node. So the criterion determines how to split data at each node. But I'm going to put that in quotation marks. What does it mean to split data at a node? Maybe that's a stupid question, but I don't know what it is. Oh, look, it drew a diagram. A bit broken, but still impressive. Of course, in a decision tree, a node is the fundamental building block. So it's a point where a decision is made or a final outcome is reached. Okay, so the leaf node must eventually tell you, are you surviving or are you dying? Okay. And there are types of nodes. There's a root. What sources are you using? Oh, Wikipedia. What other sources? Lucidchart. Decision tree. Oh, maybe I should. All about decision trees. That sounds really good. Let's copy this link. All about decision trees. Well, that's a long URL. What the hell? Remove the text. Okay. I should read that. I don't know anything about decision trees. Okay, so internal node or decision node. Oh no, wait, I skipped root nodes. This is the topmost node of the tree and represents the entire dataset. Oh, nodes represent the dataset. They contain a dataset or a split of the dataset. But that doesn't really make sense, because I would think that a decision tree tells me information for a new data, not, you know, because I have training data. Oh, but then maybe I don't quite get it. Okay, it's the starting point from which all other nodes branch out. There's only one root node, internal node or decision node. These are the nodes that connect the root to the leaves. Each internal node represents a test or a question about a specific feature of the data. Based on the outcome of this test, the data is split into different paths, leading to subsequent nodes. Oh, okay. So when it says dataset, I think it actually means one, because like in the Titanic example, I would have an entry to determine whether it's going to survive that contains all the features like passenger ID, fare, class, and that's what's contained in the root node. And then in a decision node, we pick some of the features, I think. We split it. Yeah, each internal node represents a test or a question about a specific feature. Right, so if I have a tree, then the second node would be like, is this dude wealthy? But now I guess it can use a combination of features. We'll see. Based on the outcome of this test, the data is split into different pods, leading to subsequent nodes. An internal node always has one parent node and at least two child nodes. Okay. Leaf node, these are the final nodes at the bottom of the tree's branches. A leaf node represents a final outcome or a class label. Okay, what? Did someone just call me? No. Okay, good. What data does a node hold? Each node in addition contains crucial. Okay, the test condition for internal nodes. Okay. The total number of data points, sample distribution, impurity measure, and prediction. But is this thing then holding? I'm gonna have to ask that. So, okay. So what did we learn? We learned that each node holds depending on type, holds data from the data set, which we still don't know what it is. So we're gonna ask a follow-up question. What data set is it referring to? Is it referring to training data or the data on which we make predictions? So that's one thing we gotta answer, but it holds data. It also holds a test for features based on tests. I'm not so sure if I'm ready to say that. This is the question. The node asks to split the data. It also holds a test which is executed against features. Okay, so test is executed against features. Based on this test, data is split. So we kind of have some different information. First we talked about splitting the tree, now we're talking about splitting the data. Okay. Number of samples. The total number of data points from the data set that have been filtered into this node. A distribution, the breakdown of how many of the samples in this node belong to each class. For example, a node might contain 100 samples distributed as class A 80, class, well, that sounds like training data. So, okay. So you make a decision tree and then it splits the training data, and at each node performs some kind of test, and it also has information about, you know, after we've performed these splits, this is the amount of class A that we have, and this is the amount of class B that we have. In a regression tree, this would typically be the average of the target values for the samples in the node. Okay. Impurity measure. This is the value calculated by the criterion for the specific subset of data in the node. And now it makes sense, this Gini impurity, right? Because once we're in a node, we have a sample distribution. So within the node, wait, isn't this always going to be 1? Because wait, we're summing over all existing classes. Oh, wait, actually that makes sense, because maybe, yeah, because you don't want a node to contain every single class. Oh, I see. You don't want a node to contain every single class. Actually, Genie impurity might be shit for the Titanic because it just has 2 classes. We'll see. I don't know if that impacts it. But like, if you have 10 classes and the node only contains 2 classes, yeah, so if there are 10 classes in total, some are going to be 0. Okay. Yeah, I mean, that makes sense. Although within the node, you're going to have like the probability that it belongs to class A is 20%, and the probability that it belongs to class B is 80%, and the probability that it belongs to class C is 0%, or maybe not. Maybe I'm stupid. Probably I'm stupid. It's not gonna be 1 because it's 1 minus this sum. Oh wait, it's squared. It's squared. It's squared. It's squared. Right, so we square each probability. So that gives you a smaller number. I'd have to see how that plays out in reality. But I can see how this splitting can lead to this not being equal to 1 all the time. Yeah, I mean, even if it is 1, right? Because if you have 50% and 50%, in the end, Gini would be 0.5. So this cannot be 0. What am I saying? All right. And then the prediction, the output value, it is the majority class of the samples. Okay. Let's imagine a simple decision tree that decides whether to play tennis. Outlook is sunny, samples, sample distribution, and impurity measure. And this tests whether it is sunny. Oh, this is actually super useful because if we have like, we have the class being the most like significant feature, and then this root node is probably going to test, well, is this person class 1? If it is, then we go yes, and then we test other things to predict the probability that they're going to survive, and then on top of that we improve that with other models that correct errors in gradient boosting. I can see this starting to make sense. Okay, so still this samples thing is weird. Is this from training data? Yes, this must be from training data. So in training data it had 14 samples, had 9 play and 5 don't play, and Gini was 0.459. How would that come about? You have either play or don't play. Isn't the probability... Actually, no, it isn't. What am I saying? Okay. Maths. Internal node. We test humidity. So if humidity is greater than 70%, don't play. But if it's less, then play. Okay. Okay, let's ask about the data. When Okay, so when using a decision tree, do the samples in the decision tree referring to the training data? This is not going to be fun to build, but we were saying about data structures, so clearly each root node, right, it's not going to be too fun in C++ actually, because you're going to need to be able to account for a different number of features with different types. So we're going to need some fun typing. This is definitely easier to build in Python, I think, but it's okay. The samples refer to training data. Okay. Okay, this is cool. Okay, I still don't get it completely, but it makes more sense. Makes quite a bit of sense. Here the Gini is 0 because in the sample data the distribution is 0% for class 1 and 1 for the other one. So Gini adds up to 0. And Gini changes the it seems like the worst case scenario. Yeah, 0.5 for Gini is like the worst case scenario, right? No, it's yeah, that's the highest Gini can possibly be, unless there's some factor I'm not accounting for when you're like you have an even spread. Maybe it's even because I just accounted for 50%, but if you have like 50 classes and each is 1/50, yeah, then it would be super high. Then the node would be like, oh, super high impurity, I have no idea what to do. And that's why this is used to determine whether you want to split the data. If the impurity is too high, then you should split, right? Or it should determine how you split. Okay. You don't want to have too high impurity. Okay. All right, that makes more sense. Okay, so now I know kind of what a tree looks like. This is a good diagram. This is what I should have in my head when I think about a decision tree. This is what it is. Now, the question is, how does this get trained? I want to know, how do these decision trees get trained? Okay. It's training data. Okay. So I want to know about how this tree gets trained. And we're going to use two things. We're going to check scikit-learn implementation. And we're going to ask Gemini also. Let's do that first. How does decision tree get trained? Let's be bold. Can you let's ask that later. Can you provide example Python code for training a decision tree? The funny thing is I could get the LLM to do all of this for me probably, but that's not the point. I want to learn. But if I just like gave it, I could probably just ask it implement decision trees in C++, and it would just do it. Maybe that's a fun thing that I can do on the side, just to see how it does. And if that doesn't do well, I could give it the scikit-learn code and be like, convert this to C++. That would almost certainly work. But that's not the point. Okay. That's not what we're doing here. All right. So I'm curious about training. But also how they build decision trees, I want to check. So let's see. Does this thing do anything? Use a self.tree. So where is this tree? It's not defined here. I'm guessing it's defined in base estimator. Okay, we're gonna need layers. So first we're in base decision tree and we're wondering what does a tree look like in scikit-learn. So we go to base estimator. Is the tree here? Whoops, that's not how you spell it. It's like this. Wait, it's not? Oh, is it provided in the constructor? Where does it get the tree from, bruv? Tree. Where does this come from? Does the language server know? Okay. It gives me a bunch of answers. What is this? Oh, it sets it in some method. In what method? What method is this? Whoa, this is a huge method. Fit. Okay. But wait. Okay, so you cannot instantiate this class and call max depth until you call fit. And this is where apparently most, if not all, of the magic happens in the fit method. Okay. So this is interesting. What class is this? Base decision tree. Okay. And there is a tree class. Fit method seems like it does a lot. Should be explored. The fit method should be explored. Okay, so let's check out the tree class. Where is it defined? Here it is. It's it has a label, node ID, and children. That's it. Interesting. I wonder how they store data. Do they just dynamically? This is called Reingold Tilford. Okay. What is Reingold Tilford? Whoa. Okay. Search engines are crap, so let's use this. Scikit-learn. Actually, we can do that here. Scikit-learn refers to Reingold Tilford in trees. What is Reingold Tilford? Or who is Reingold? Is that a person? Oh, that's two surnames. It refers to an algorithm created by Reingold and Tilford. Is there not a Wikipedia page for this? That's so weird. There isn't. What? In a 1981 paper by Edward, Tidier Drawings of Trees. Paper, Ringgold, Tilford. I want to see the paper. Oh, it's a functionality for drawing trees. But it doesn't seem... Oh, is this the paper? Oh, it is. Nice. Oh, published in the legendary IEEE. Nice. Various algorithms have been proposed for producing tidy drawings of trees. Drawings that are aesthetically pleasing and use minimum drawing space. We show that these algorithms contain some difficulties that lead to aesthetically unpleasing, wider than necessary drawings. We then present a new algorithm with comparable time and storage requirements that produces tidier drawings. That's so cool. Generalizations to forests and MRE trees are discussed, as are some problems in discretization when alphanumeric output devices are used. Bro, things they had to worry about back then. It's probably like storage. What's that? 2 kilobytes of RAM. Oh my gosh, is this Fortran? It could be Fortran. Legendary. Okay. It's epic. But if that is referred to drawing trees, then I'm reading it from... Okay. Oh, because there's a draw tree class. So this is maybe not the right implementation. Maybe this is just used for drawing trees. Maybe this is not actually the thing they use. Tree. No. Where's fit? Am I in the right class? No, base decision tree. Go there and show me what is a tree. Okay. Yep. It takes 3 parameters. Does this one even take? It does. What? And outputs. Okay. It must be a different kind of tree. Nav, bro. It has to be a different one. Class tree. Oh my days. No, that's not what I want. How do you say space? Space 3. 3 bad version, 3 no version, 3 builder. Oh, PyX. Is that thingy that works on the GPU? Or is that just CPython? No, that has a different extension, but I'm pretty sure it refers to this one, right? Array-based representation of a binary decision tree. Yeah, this seems like... Well, what is this using? Because this is not Cython. In Python, what is the PyYX extension in the context of Python? I mean, I know it's for building Python extensions without using the dirty C or C++ languages, but I never saw PyX. Oh, it is Cython, really? Okay. Yeah, it's Cython. Thankfully, Cython, the entire point of it is to be readable. So that's cool. Yeah, this tree is quite capable. Add node, precise. Oh god, what's the point of using this like funny wrapper called Cython if you're still gonna do memcopy? That's like quite low level. I feel like it's like instead of learning and basically an entirely new language, Cython, isn't it easier to just write it in C or C++? And then you don't have to worry about adding a whole new layer of Cython and potential Cython bugs. How robust is Cython? Like, how many issues does it have? Yeah, 1.3k issues. Like, what if you run into one of those? I mean, why not just go direct to the grain? But okay, whatevs. Okay, a tree data structure is defined in scikit-learn. Tree data structure in scikit-learn is defined in sklearn tree.pyx. Okay. Oh, nice. They write some text summary. The binary tree is represented as a number of parallel arrays. Why do you call them parallel arrays? Do you just mean a multi-dimensional array or something else? The ith element of each array holds information about the node I. Node 0 is the tree's root. You can find a detailed description of all arrays in tree.pxd. Note, some of the arrays only apply to either leaves or split nodes respectively. Is that really the best way to make a tree? In this case, the values of nodes of other types are arbitrary. I mean, it probably is the best way, because if it weren't, someone would be yelling. Oh, cdef struct node, parent info, class tree, tree builder, and tree pruning. But why is there another tree here? Hello? Interesting. Resize, resize C, and the array. Computing depths, feature importances. So I'm wondering, should I just implement my own tree, or do I use someone else's tree? Nah, I'm gonna implement my own tree. We're not noobs. We'll implement the tree. I don't know if I'm gonna go for the same data structure as scikit-learn went for. We'll see. We'll see. Okay, but I got distracted. That wasn't the main quest. I was wondering about training. Okay, let's check about training. So what does fit do? What's the best way for me to ask an LLM, what does this do? Because I don't want to read through all of this to understand what it does. Although, I mean, fit should beat the train, right? There's predict and there's fit. Yeah, I mean, this should be the train. But just out of curiosity, I want to see, does GPTel have some cool way to be like, yo, what does this do? Because I don't really want to copy this or give it as context. I would like it to have all of the context. Yeah, it's not gonna work. I would have to give the entire file as a context and then be like, what does this do? Okay. I'm not gonna do that. It's fine. So let's see what fit does. So random state equals check random state self dot random state. Should I mean, this would probably be easier to understand as it runs instead of just reading the code. Yeah. So I'm thinking, but you know, I mean, setting a debugger is not the most fun thing to do, but I also have a feeling that setting this project up so that I can modify the source code is not going to be too trivial. Because I just want to run scikit-learn so that I can run this stuff and see what it does with a debugger, so that I have all of the values, so that I can see what is random state directly instead of having to, you know, go to a description or whatever. I mean, even though I can guess what random state is, but I'm gonna have problems elsewhere. Okay, so let's see. How do we set this up? Oh, they have makefiles. Cool, bro. README. Scikit-learn, installation, dependencies, and no, that's not what we want. Yeah, let's check it this way. I don't like reading these RST files. Wait, contributing code, how to pull request, building the documentation, crafting a minimal reproducer. No, I just want to know how to set up the project. I don't think I'm gonna find that here, unfortunately. Does it have... Should I ask either? Might as well. No, don't run pip install. Wait. Oh yeah, pip install for either. Yeah, go ahead. Update yourself. In the meantime, doc, does it have something like building? Has contributing, but that just links. It has contributing, but I think that just links here. That's this one, right? Yes. Contribute code. Oh, am I so bad? Wait, what? That's not... Okay. Oh, they don't have it in git ignore. That's annoying. Yeah, what's new in Aider? Oh, crap. Okay. So ask, is there documentation about how to set this project up for development? Aider is not the best tool for asking this kind of question, but maybe it will find something, because I don't like navigating this website. I'm bad at it. I'm bad at it. Okay, I'm just bad at it. Yes, go ahead. That's not the file though. I was gonna go read that file. Oh no, did I break Emacs? I might have broken Emacs. Yep. Damn. I think Aider breaks Emacs, unfortunately. That's unlucky. Crazy, bruv. Okay, open the terminal. Let's go. Now it's gonna open 2 terminals. There they are. Kill all Emacs. Thank you. Okay. New version of Emacs. Let's go here. Okay. Now the question is, when you have 2 monitors, how do you... Bro, that's crazy. I removed the title bar, and now I have no idea how to maximize Emacs, bro. Wait. Does Windows... Yes. Wait. Wait, huh? It splits things by... And I cannot drag it here? For realsies. That's crazy. I hate Windows. Alright. Windows. How to move a window between a multi-monitor display. I should have asked Gemini Flash. Windows key plus shift. I don't know if that works. No, that does not work. Wait. But when I maximize it... Okay. So the key is pressing shift. Nice. But is there a more robust way? Okay, that's just wonky. Whatever. Okay, where was I? Right, contributing. Projects, scikit-learn. Right, Aidermax broke Emacs before telling us anything, but it wanted to look into contributing. But isn't that just the link? Wait, what? Contributing. Yeah, this tells you nothing about... Oh, wait, this looks good. So, in the first few steps, we explain how to locally install scikit-learn and how to set up your Git repository. Create a GitHub account. Okay. They really tell you everything. Okay. Oh, can't I make a virtual environment? This is useless. What if we search for venv? Advanced installation. Building from source. Why is this so buried? Oh my god. This is hella buried. I mean, maybe I missed some link somewhere, but damn. Okay. Install a recent version of Python. Right, I have Python 2 installed, don't worry. It's not always necessary, but it's safer to open a new prompt. Right, so they recommend using Conda. I'm not the best at Conda. Maybe it's time that I get good. I'm gonna try to get good at Conda. But for that, I think I need to modify my bash RC, which contains secrets. So let's do that off screen. Right, where is Conda? Okay. So if I do Conda, okay, this is terrible, but I don't know how to use Conda properly. So unfortunately, we're gonna have to yeah, let's just ask for basics. Quick reference, how to use Conda for Python on Linux. Installation, run, activate, Conda create. I think we're gonna need to do that, so let's do it. Conda create name. Let's make it what should be the name for my environment? Whatever. Scikit, my scikit. I don't know if the name. Wait. What's the latest version of Python? Let's just use the same one I have. 3.10. Okay. Do I accept the terms of service? I guess. What's this? Anchors is OpenSSL Python. Read line, setup tools, SQLite. Okay. Yeah, this is fine. Let's go yes. To activate this environment, use conda activate. Conda activate my scikit. And now if I go Python version, it should be 3.8. Okay. I see how you work Conda. And where do you put all these files? I'm guessing somewhere in the home directory. So there's activate, deactivate, list environments, remove an environment, export and activate. Oh, okay. Install a package. But wait, does it automatically install? Wait, does it automatically install pip packages? That'd be crazy. I think you can use conda with other software, not just Python. But okay, whatever. This thing tells us we can use it this way, so whatevs. And if you install Python, conda environment. Okay. So I'm gonna have to do this again so that I can install it in my environment. So actually, let's do it this way. And we're gonna do conda install C conda forge, and then we're gonna need numpy, scipy, cython, meson, python, and ninja. Okay, is this gonna work? I think it will. I wonder where is it using pip, because you cannot install Python from pip. Wait, no, these are not Python dependencies. What am I saying? But numpy is. How does it know? I guess it has its own package manager. Okay. Anyways, we did that. Install a compiler with OpenMP support for your platform. What the heck is that? Scikit-learn docs saying the thing below. What is OpenMP? No. Abort. What is OpenMP? Response to echo area. Prompt from mini buffer. What is OpenMP? Okay, the following packages will be updated. Wait. Is it replacing system packages? Whatever, I don't care. Wait, what messages? Open multiprocessing is an industry standard API specification for writing shared memory parallel programs in C, C++, and Fortran. It provides a set of compiler directives, pragmas, runtime library, to express parallelism simply and portably. Why have I never heard about this? Make it easy to parallelize loops and regions of code for multi-core CPUs. Wow, really? That is crazy. And GCC supports this. That is awesome. That is really cool. Okay, build a project with pip. Pip install editable this. Okay. Wait, so if I now go to scikit-learn here and I copy this, go there and do pip install editable this verbose no build isolation config settings editable verbose equals true. Let's try. Okay, of course that doesn't work, but let's just check here. Yeah, it's still good. Okay, what's going on? Full log. Scikit-learn requires less. But I just installed Cython. Cython? Bro, why did you install like an ancient version of Cython? What? That is so weird. So what if I say conda update Cython? But why did you install an ancient version of it? What? That's so weird. Okay, whatevs. Where's my conda command? I did it properly, right? I don't know. Whatever. Let's try it now. Oh gosh, I lost the command. Pip. I don't want an alternative to conda. I just want to run this. Is it gonna work? Yeah, it ends in dev0. That's a good sign. Is this Cython? Yes. Well, it's Ninja running Cython in order to generate good stuff. Compiling C++ object. Nice. The problem is that it would be a pain in the neck to get Emacs. Well, not really, but it would not be fun to get the language server to recognize things. These are warnings, right? Not errors. Yep, okay, that's good. I mean, it's not good, but it's not breaking. All right. Now let's test that it works. Show versions. Yeah, we have it. Nice. Now I haven't done Python debugging in a long time. Should I use VS Code? No, because there's this conda environment nonsense. I mean, Visual Studio Code probably supports that pretty well. Yeah, Visual Studio Code probably supports conda environments. But I'm gonna do that next time. I'm getting pretty tired. I'm gonna stop for now, and we'll continue building classification and regression trees another time.